Hello and welcome to another session with EdupediaWorld.com, your favorite portal for online education. Continuing with regression analysis, today we shall see how to derive the formula to find the regression coefficients. To recall, we have seen that for a bivariate data, there will always be two lines of regression depending on which of the variables is independent and which is dependent. The first, in case when y depends on x, then the equation would be y equals a plus bx, where b gives the rate of change of y per unit change in x and a is the average value of y when the value of x is 0. Similarly, when x depends on y, then the equation would be x equals c plus dy, where d gives the rate of change of x per unit change in y and c is the average value of x when the value of y is 0. Coming to derivation, let's take the first formula, the first equation, that is the equation of y on x, which is given by y equals a plus bx. If you recall in the previous session, when we solved the problem, we just had to calculate the values of a and b to get the regression equation. So here, first we will find a suitable formula to calculate the values of these two constants a and b, and this is done by the method of least square. By the use of the method of least square, we will get the line of best fit. Now, what is meant by the line of best fit? Line of best fit means a line which would fit in the best manner among the variables or among the points, among the observations of x and y. A line which will be the least deviated from the actual observations. Let's understand this by way of an example. Let's say we have 2 points. Say this is my x1, y1, the first point, and this is, say, x2, y2. We know that the regression equation is the equation of straight line. If I'm asking you to fit a straight line to these 2 points, it's simple. What we do is we will take a line which will pass through both these points. Okay, a straight line passing through these points, and that's the line of best fit. Why? Because the deviation from the actual observation x1, y1, x2, y2 is 0. There's no deviation, there's no difference between the point and the line. Now if we proceed and if we take, let's say for example, we have a third point. Now this third point could be here or it could be anywhere away. If it is here, then again it's trivial, but usually practically it doesn't happen so every time. Like, we do not get all the points in a straight line straight away. We have slight deviations, slight errors. Now in case if we have a point here, we will draw, when we draw a straight line, the maximum it could pass only through these only through 2 points. One of the points will be left out. Okay, now there would be some difference between this point and this line. Okay, there's some deviation, or maybe you can have a line which will go through these 2 points. Let's say this point and this point, then there will be some deviation from here. Okay, similarly we can have a line which could which would pass through these 2 points, leaving this something like this. So each time, each line you draw, there will be some deviation between the line and the actual point. We need to pick that line which will have the minimum deviation. Like for example, if we take this line, say line number 1 and line number 2, we see that the deviation here is lesser than the deviation here. Therefore we can say that line 1 is better than line 2. Okay, so of course when we are doing this here, we are doing it by trial and error method, and since we have just 3 points, we may be able to do it. But in case if we have several points, let's say for example, if we have a graph here where we have, say, 1, 2, 3, 4, 5, 6 and so on. If we have so many points, let's say we pass a line like this, we do not know. We can have a line like this, we can have a line which could go something like this, which can have a line which may go like this, and we do not know which of these lines would be the best. We can compare and say which is better, but then drawing several lines and doing this is going to make life difficult. Now you must have understood what is the line of best fit. A line which for which the deviation from the actual observations are the minimum. Okay, and we will find this line using the method of least square. We'll see shortly what is this method of least square and how are we going to do this. Okay, and we will use the same method for the second equation also, that is equation of x on y, where x equals c plus dy. We'll just derive the formula for one of these, and the same logic, same method would be applied in the second one, which you can do yourself. So let's now see in detail what's this method of least square and how we do this. Okay, let's say we have the observed values x, I and yi as, and let's say we have the points here as x1, x2, x3, x4 and so on. Similarly in y we have y1, y2, y3, y4 and so on. Okay, we know that for in the regression equation is y equals a plus b x, right, the equation for y. And just to differentiate between this observed y and the equation of line, because this is actually the equation of this line and these observed values are these ones. Okay, so let's just to differentiate, let me call this as yc. Okay, now I need to find the deviation. As we saw, I need to find the deviation. To find the deviation, let's write that here. We have yc, the equation of yc as in the first case it will be a plus b x1, the second case it will be a plus b x2, a plus b x3 and a plus b x4, because a and b are the constants. Okay, and so on, it goes on. Now you see, we need to find the deviation and not the difference. So let me draw a neat graph here and explain to you once again. Okay, let's say we have this is y and this is x. Let's say we have the first point here x1, y1. We have another point x2, y2. We have a third one x3, y3, and we have a fourth one, say x4, y4 and so on. Okay, let's say I have a equation or a equation of a straight line. Let me use a different color, going like this. Okay, now here this is my, let's take just 2 points as an example. Let's say here this is a point where the value of y is y4, this is y3. Okay, if I project this on the line here, this will be the point and here it's going to be this one. Okay, this is my, say, yc3 and this is yc4. If I have to find the difference between yc and and the observed value yi, okay, the difference between these two, in this case, okay, let's say the value of y3 is, say here this is 5. Let's say this is 5 and this is, say, 6. So the difference between this will be 5 minus 6, which is going to be minus 1, and in here let's say this is, say, 7 and this is 8, so it will be 8 minus 7, which is going to be 1. Now what we see is that if we take the difference, sometimes the individual observation is more than the value on the line, sometimes it's lesser than the value on the line. So the difference will have magnitude and that will cancel out each other. If the value is minimum, that's going to cancel out each other. Therefore I'll have to eliminate the sign, that is, I'll have to take the deviation and not the difference. What I'll have to do for that is square these values. So when you square these values, you will have the square of -1 and square of 1 as all equal to 1. Okay, so we need to take the square values here of the deviations. First let's find the difference. We have got the yc. The difference will be yi minus yc, and that's going to be yi here is y1 minus yc is a plus b x1, right? So this will be the difference. Similarly in the second case it will be y2 minus a plus b x2, y3 minus a plus b x3, and so on. Okay, so I need to take the differences or the deviations from these, and then I'll have to square them. Squaring them, you'll have y1 minus a plus b x1 square, y2 minus a plus b x2 square, and so on. You'll have to find the squares of all of these. Okay, hope it's clear. See, basically in the method of least square, what we do is we take the deviation from the observed values and their projection on the imaginary regression lines. Okay, we take the deviation from these, that is we take the difference yi minus yc and we square them. Okay, so here we have got this, and then we need to take the sum of all these deviations, because we need to minimize the sum of these deviations. The deviation should the total deviation, the sum of the deviations from every point, you know, we need to take into consideration all of these points. That should be minimum. Okay, so we need to take the sum of these, and that's why the method is called the method of least square. Okay, after taking the sum we will have to find the minimum point, the minimum value of the sum. Okay, so let's take here, we have got the differences as, let me just write the difference, it's yi minus a plus b x I, right? This is the difference. We need to square this difference. I've squared this, and then we need to take the sum of this. Okay, so basically we will have, let me give this a name as, say, s. Okay, so s will be equal to the summation of the difference, the square of the difference between the observed values and the estimated values. Okay, we need to minimize this deviation. Okay, and this is what we call as the method of least square. Let's see how to do this one. Okay, in case if I have to minimize this value, what I'll have to do, I'll have to differentiate this partially, differentiate s partially with respect to the constants a and b. Okay, differentiate s with respect to a and b. So here we have the value of s is summation yi minus a plus b xi square. First let's differentiate this, differentiate partially with respect to a. Okay, so when we differentiate this partially with respect to a, we will have differentiation of s with respect to a equals, we have a square here, so we will have 2 times summation yi minus a, let's open the bracket here, so we'll have minus a minus b times of xi. Okay, and when we take the values inside, we will have this when we differentiate with respect to a partially, of course this will be 0. This here we will have minus 1, so that will come over here, minus sign, minus 1, and this again will be 0. So we'll have minus 2 times summation yi minus a times minus a minus b times xi, and let's equate this to 0. Okay, so now this will become, when you take it, you know, it will become summation yi minus a minus b times xi equals 0. Okay, Now let's apply this summation over all of these. So we will have summation yi. Now when you take a constant and sum it, we will have n times the value a minus b times summation xi equals 0. Okay, now we need to find the value of a, so let's divide this by n. What we will have summation yi divided by n minus a minus b times summation yi by n. Okay, let's take, and this is equal to, of course, equal to 0. So let's take a to the other side. We will have summation yi by n minus b times summation xi, right? This is xi. Summation xi by n equals a, because minus a when goes to the other side become plus a. Now what is this summation yi divided by n? Summation yi divided by n, we know, is nothing but the average value of y. So this is nothing but average value of y. Similarly here, this is your average value of x. So now we will have y bar minus b times x bar equals a, and that is the formula to find the value of a. If you recall, in the previous session we have found the value of a by using this formula. That's the average value of y, mean of y, minus b times the average value of x. Obviously, to get the value of y, a, we need to know the value of b also. Okay, let me call this as equation number 1. So I need to get the value of b, and that is obtained by, differentiating this partially with respect to b, that is finding the minimum value with respect to b. Okay, so let's do that as well. We have s equals summation yi minus a plus b xi square, and we need to differentiate this partially with respect to b. So when you differentiate this partially with respect to b this time, you will have, say, differentiation of s with respect to b, and that will be equal to, again we have a 2 here, so we'll have 2 times summation yi minus a minus b xi. Okay, the whole thing, again when we take the terms inside, this is yi, this will be 0, this again will be 0, b is here, so with this we will have, of course, minus, so we'll have minus xi, and that's going to be equal to 0. Okay, now this 2 and minus goes to the other side, will become 0, so we'll have this equal to summation yi minus a minus b xi times xi equals 0. So let's multiply this and apply the and open the bracket here. So we will have summation yi into xi in the first term minus, we'll have summation xi times a, and then again minus b times summation xi into xi, which is summation xi square, and that's going to be 0. Okay, is it clear? We have, what we are doing is we are taking this summation of yi, multiplying it with xi, we'll get the first term. Second term we'll have summation a, and a being constant comes out of the summation, so we'll have minus a times summation xi, and the third one we will have minus b times summation xi into xi, summation xi square. Okay, next let's take the value of a from the previous equation. What was the value of a? A was equal to y bar minus b times x bar. This was our first equation, right? So substitute that, substitute a from equation 1 in here. So we will have summation yi xi minus, in place of a we will have now y bar minus b times x bar times summation xi minus b times summation xi square. Now solve it for b. We will have summation yi times xi minus y bar times summation xi, minus to minus will make it plus, b times x bar times summation xi minus b times summation xi square equal to 0. Okay, so let's take all the b terms to the other side. We will have summation yi minus summation yi times xi minus y bar times summation xi, okay, equals, when this both of these goes to the other side, we will have b times summation xi square minus b times x bar times summation xi. Okay, now let's take b common here, so we'll have summation yi xi minus y bar summation xi equals b times summation xi square minus x bar times summation xi. Okay, so now this is the formula to find the value of b. What we can do is to bring the form in which we had solved the problems in last time. Multiply this equation. Let me call this as equation number, say, let me call this as equation number 2 and this as equation number 3. So let's multiply equation 3 by n. What we will have is n times summation yi xi minus n times y bar times summation xi equal to b times n into summation xi square minus n times x bar into summation xi. Okay, now we see here what is the value of n times y bar. We know y bar is equal to summation y divided by n. So of course y bar multiplied by n, y bar multiplied by n will be equal to summation yi. Similarly here x, we will have n times x bar equals summation xi. So now substitute that here, we will have n times summation yi xi minus, in place of n into y bar we will have summation yi summation xi equals b times, all these can be taken to the other side in the denominator, we will have b times n into summation xi square minus, you have this will become summation xi. Okay, so you'll have summation xi into summation xi is summation xi the whole square, and this is precisely the formula to find the value of b. Let me call this as equation number 4. So we have these two equations, equation here, this one, the equation for a, and this one, the equation for b. Okay, let me write that neatly here. B equals n times summation yi xi minus summation xi into summation yi divided by n times summation xi square minus summation xi the whole square. Okay, fine. So this is our formula to find the values of a and b. Okay, so the whole formula is this way. We have in fact found this form of the formula: b equals n times summation xi yi minus summation xi into summation yi divided by n times summation xi square minus summation xi the whole square, and a equals y bar minus b times x bar. In the same way, we can also find the formula to find the value of d and c just in place of taking the difference between yi and yc. If we take the difference between xi and xc, we will get the formula of these c and d. Okay, rest of the thing, the procedure, everything is the same. But what about these? Of course, we also have these forms of the formula, and this in particular will be helpful in deriving a relationship between regression and correlation. If you remember, if you recall, the formula for correlation was given by the covariance between x and y divided by sigma x multiplied by sigma y. So we see a marked a relationship between these two, a similarity between b, d and r. We can use this similarity to find a relationship between the regression coefficient and the correlation coefficient. We shall see these form of the formula and the relationship between regression and correlation in the upcoming series, upcoming sessions. Thanks for watching Edupedia World videos.